Over the study guide, page 4, there's 2 challenge problems. Okay, so the first one is a momentum problem where some carts are colliding. And so what you should do if you get a challenge problem like this is you should look at like what the momentum is before the collision and what it is like afterwards. This is kind of how we've set up tables previously. So before, you have an 8 kilogram cart, and so what we're going to be doing is getting the momentum. So momentum, remember, is equal to mass times velocity. So we're going to take 8 kilograms times 4 meters per second, and so that's going to be equal to 8 times 4 is 32 kilograms meters per second. All right, and it's going to the right, and it's going to hit a 4 kilogram. So this is cart 1, this would be cart 2. It's going to hit a 4 kilogram cart, and it's going to be moving to the left. But remember, to the left it has a negative velocity. So negative 6 times 4 is a negative 24 kilograms meters per second. Now what I like to do is add up the total momentum before. So 32 plus a negative 24 is equal to 8 kilograms meters per second. Now afterwards, we know that we have cart 1 and we have cart 2, let's say. So immediately after the collision, the 4 kilogram cart moves to the right at 3 meters per second. Okay, so afterwards, the 4 kilogram cart, so this one's the 4, so it's going 4 kilograms, it's going to the right, so that's the positive direction, 3 meters per second. So afterwards, it has a momentum of 12 kilograms meters per second. And remember that if we add up the momentum of cart 1 plus cart 2, it has to equal what the momentum was before, which is 8 kilograms meters per second. So what number plus 12 equals 8? And the catch is it has to be a negative number. So it's negative 4 kilograms meters per second. So what is the speed and direction of the 8 kilogram cart after the collision? Well, we know that from the momentum equation that momentum equals mass times velocity, but if you rearrange the equation, velocity equals the momentum over the mass. So if we take the velocity equals the momentum, which is negative 4, I'm kind of running out of room here, kilogram meters per second. I know you can't see that, but I'm going to divide that by the mass, and it is equal to 8 kilograms because that was the mass. So we know that if we took 8 kilograms times x, it has to equal negative 4. So basically the velocity is negative 4 divided by 8. So the velocity of that cart is a negative 0.5 meters per second. I kind of ran out of room there because negative 4 divided by 8. The negative sign, that means that when it says the direction, it's moving to the left. Okay, so that's negative 5. So what you can always remember is that the total momentum before has to equal the total momentum afterwards. Then you can find the momentum of the unknown, and then you can just plug that into this equation and solve for the velocity of the unknown. Okay, so this one, you have a cannon. Okay, so here we have a cannon. I know I'm a terrible artist, but there's the cannon. Okay, and basically it has a cannonball. All right, but the cannonball is sitting inside the cannon. All right, or that's actually a tennis ball. Okay, and anyway, you add fuel and then you shoot it. Okay, and so basically the momentum before has to equal the momentum afterwards. So basically we have the cannon, and then we have the ball. Now the momentum before, remember momentum equals mass times velocity. Well, if the cannon's not moving, the velocity is 0, so the momentum is 0. And the ball's momentum also isn't moving, so its momentum total before is 0. Okay, so this is the before. 0 plus 0 is 0. Okay, but afterwards, okay, so afterwards, they add fuel, wait for its vapor. The explosion has ground in the ball. Okay, the photo gate determines the cannon recoiled backwards. So the cannon had a speed of 7.8 meters per second. So what we got to do with the cannon is we got to find the momentum afterwards. Okay, so we're going to use momentum equals mass times velocity. So what we're going to do is we're going to put in the mass, 1.27 kilograms, times the velocity, but the velocity is going backwards, so we're going to make it a negative number, 7.8 meters per second. So the momentum of the cannon, if you take that, it equals something like 9.906 kilograms meters per second. Well, that's the cannon. Well, the ball then, remember that the total momentum before, so if we take this 9.906, what do we have to add to that? What do we have to add to that to give us 0? Well, the answer is a negative 9.906. So that's what the ball has. Okay? So the ball has to have the same momentum but in the opposite direction. And then it wants us to find the speed of the ball. Remember, momentum equals mass times velocity. We change it around. Velocity equals momentum divided by the mass. Velocity equals a negative 9.9. Well, actually, I kind of messed this up with the cannon. It would be negative. The tennis ball would be positive. I knew that should be positive. Okay, I forgot to apply my sign there. 9.906 kilograms meters per second. We're going to divide that by the mass of the tennis ball. So 54 grams. Oh, we can't work in grams, remember? So you got to take grams and you got to change it to kilograms. Oops, grams there. So 54 divided by 1,000 is 0.54 kilograms. So then we're going to plug that in over here, 0.054 kilograms. And so the velocity equals 183.4 meters per second. Okay, so basically just remember with these momentum challenge problems, if you can figure out the momentum before, in this case it equals 0, the momentum afterwards, if you take the cannon, so this was the cannon right here, I forgot to make it negative, but it was a negative there, I just forgot the sign, but if it's negative 9.906, the ball has to be positive 9.906 because the momentum before has to equal the momentum afterwards. Disregard that. And then, anyway, then you can use that to figure out the speed of things there. All right, that's it for that video.